Great to have Jim just talk for a little bit to you, and some of you get a chance to meet him around tomorrow and what have you, and so we're going to have a good time listening to him tomorrow night. But here's the man himself, Jim.
Well, good, thanks. Yeah, I'll be around all day tomorrow and tomorrow evening, and anybody who wants to talk airplanes or anything about the design of it or what not to do and what to do and all that, it's really easy to get me to talk that way. I don't even have to start twisting the arm. I talk about 80 words a minute with gust to 110. Shouldn't be in this round. I tell you, it was really neat to come in here today and see all those airplanes parked out there. Not only was it nice to see so many, but boy, the way you people have been taking care of those things are just absolutely gorgeous. And some of those paint jobs and paint schemes, and the $10 you put into the extra instruments and everything. That's per knob, I guess. But no, it really looks real good out there, really interesting, and made me feel real good about it without a doubt. You got a fantastic organization. It really is. And the fact that the airplane's not in production now probably means that the organization needs it even more than anything. But the beauty of it, in meeting with all of you that I have already, is that not only can you take care of some really good, important business and information about the airplane, but you also seem to have the ability to have a little bit of fun and enjoy yourselves too. So it sounds like a great way to go. But we're looking forward to meeting with all of you tomorrow during the day, anytime, and then again tomorrow night.
Jim Bede, our honored guest speaker.
Well, I really cannot begin to tell you how much I appreciate being here. Not being prejudiced, biased one bit, I can honestly say you are the greatest people I've met in a long, long time, and you fly the greatest airplane I know about. And how could I be prejudiced about something like that? But in all seriousness, when Ken gave me a call here several month or two ago or something like that, we chatted and sent me a lot of the back issues and everything else. I was aware of the organization, of course, and knew that it was around, and pretty well believed that it was a lot like many of the other organizations. Generally, they pick up a trend. They either become purely a social group, or they purely want to go travel around, or whatever it happens to be. But I was, well, first, tremendously pleased to see all those doggone beautiful airplanes out of the airport when I arrived. But to meet with you people, it's just amazing. Everybody is 100% happy, pleasant, courteous, and you're fun-loving, and yet at the same time you get down to business and do a lot of important things, and I haven't heard anybody arguing and squabbling about hardly anything. It really is an honor for me to be part of this thing. I just love it. And you're never going to be able to keep me away from it again. I'll be back all the time. I thought what I talk about tonight is sort of break it down into three things. One, give you a little bit of background on the Bede 1 when it started, the beginning of the Yankee, and some of the fun and some of the interesting things that occurred with it. And I'm working on another new little two-place jet airplane, so I'll talk about that a little bit. And then maybe the third session we can break up into just questions and answers. I'll ask a lot of questions, see if you got any answers. I got to tell you the one story. I mean, I know we just came from eating and it was fantastic food, but you know, a little humor doesn't hurt either. There was a story about this drunk. He is really bombed, and he staggers into the bar late at night. The bar is about ready to close. And he walks in, give me a beer. The bar, no, come on, you've had enough. No, give me a beer. No, one beer. All right, one beer, and that's it. So the guy's starting to drink the beer, and he says, hey, you got a dart set. I'm going to play darts. The bar said, no, come on, the darts are sharp. You're going to get hurt. No, let me play with the dart. Now, he's one dart. All right, one dart, that's it. So the drunk was over and ready to throw the dart, and he said, hey, if I hit the bullseye, I get a prize? Barton, yeah, sure, go ahead. He throws, he hits the bullseye. He said, all right, where's my prize? Barton, oh my gosh, what am I going to give? He said, oh yeah, I found this turtle I was going to take home to the kid. It's in the back in a box. I'll give him that. So he goes back there, gets the box, hands the drunk the box, and the drunk leaves. About 6-7 months later, same thing. Just about closing time, same drunk staggers in. He wants a beer. No, or one beer. All right, one beer. Then he wants to play darts. No, one dart. Okay, one dart. Gets up there ready, throws it again. And he said, hey, if I hit the bullseye, I get a prize? Barton, yeah, sure, go ahead. And he throws it, he hits the bullseye again. He's all right. He says, where's my prize? I want the same prize I got the last time. I said, yeah, I remember, what I gave you. He said, you gave me a roast beef sandwich and a hard roll. Makes it rough on turtles, doesn't it? Anyways, the Bede one of the Yankee literally started in its conceptual design about 1960. And I laid out several drawings and several sketches of the thing. And what I had in mind at that time was an airplane that I wanted. It wasn't a situation where a bunch of board of directors all sat down and said, okay, what's the market need? And how much money can we make this way or that way or anything. That wasn't it at all. It was strictly what kind of airplane would I like to have? What kind could I go out and buy? A store-bought one now. And nothing was available that even came close to anything I would have liked at the moment. And I knew that technically there were things that were done that we could save some weight in an airplane, we could make it strong, we could make it clean, it could go fast, we could use a modest-sized engine and so on. And that evolved. Now, EA was around and home-built airplanes were starting around, but they were steel tubes and fabrics and a few things like this, and I really didn't get turned on by that too much. But the idea of making an all-metal airplane and the idea of bonding it was really intriguing. But that was a concept that it was impossible to do for a home-built airplane. So the Bede one of the Yankee never was intended to be a home-built airplane because there was just no way somebody could build an airplane like that. But when I started to get into it, started going further with and into the calculations and actually started to do some of the drawings, I had a lot of criticism. A lot of people in the aviation business and everything else just, this is ridiculous. Piper at that time had the Piper Colt. Cessna had not yet started with the 150. And everybody says, why make a two-seat airplane? I mean, it's ridiculous. You can make a four-seat airplane for the same price, make it four-seat and what have you. And I said, no, that really isn't the case. You can make a lousy two-place airplane for about the same price as a lousy four-place airplane, but you can't make a good one that way. And at that time, there was 86,000 airplanes in the United States, and 48% of them were two-place airplanes that were over 10 years old. They were the Arankas, the Champs, the T-Crafts, the Cubs, and things like that. So that's what the Bede 1 was supposed to be. It was going to be a metallized, modern version of that, and I figured, gee, if we could sell it to those type of people, we'd have something really good there. It's interesting when you start in on a design, the one thing you have to do is start with the clean sheet of paper. I mean, don't ever use anything you did before, because it's easy to do. If you've already designed a wing once before, it's the nicest thing to just take those drawings out and say, well, now this one's bigger or smaller, let's scale it down, whatever we have to do to it. It's easy to do that way, but the disadvantage is that it may not be the best design because it was laid out once before for a certain way, now is not the time. And the thing I wanted to do in the case of the Yankee was to get it as simple of an airplane as we could, reduce the number of parts, get the cost down, get the maintenance down. It's one thing to design an airplane and build it and sell it. A Republic way back at the end of the war made the CB. And he said, all we got to do is mass produce the thing. If we mass produce it, we can get the price down. If we get the price down, we can sell thousands of them. Well, they were right except for one thing. They took this very complicated airplane called a CB, which everybody thought they'd like to have an airplane go fly up in the lakes and land and do all that sort of stuff with. And they decided to mass produce it. And they knew they were losing money on the first several thousand and maybe even more. But they thought once they got it into production, it would all balance out. Well, the only thing about it was the airplane was a big, clumsy airplane. It had a lot of parts on it. So, even if they could have made enough of them and gotten the price down, what killed it was the fact that once they got out there, once a man could afford to buy one, so much down and so many monthly payments on a thing, after a year or two, he found that to maintain the thing was costing twice as much as it was to buy the thing. And then he realized it was totally out of his class, so he had to sell it. As soon as the first and second years started getting on the market, there was no more new sales because the guys had to get rid of it, they couldn't afford to keep it. And so the trick was not just to get the cost of the airplane down, the trick was to make it a simple airplane, so they could be easily maintained and easily operated, and something that would last and last forever. And if you can make it last, then of course there goes your maintenance. You know, on the wing on the thing, here's a tubular spar, just a number of metal ribs in it, 2 sheets of skin wrapped around, and everything else. And when I had one of our first meetings with the FAA and a certification of it, this meant all the local FAA people and the top regional managers were there and everything else. This is for engineering manufacturing for certification. And we sat down and we started talking about things. And one of the FAA guys says, you have no inspection plates on the bottom of your wing. And I says, yeah, I know that. I says, now nobody ever had. Everybody had inspection plates. I said, but there's no cables in there. There's no push-pull rods, no bell cranks, no nothing. It's a torque tube, flap, aileron, several parts, and that's it. Yeah, but you got to have, you know, a inspection plate on there. You must do that. And I said, but look, you can take the wing off easy, and you can take the tip off. It's only 4 feet to the middle. And he says, but you know, every wing has to have an inspection plate. I said, all right. Where do you want me to put one? You know, I'll put it in. I don't need it anyway. Finally, after a big argument, and this guy was really serious, you got to put inspection plates. We always had inspection plates. The Wright brothers had it. You guys do too. You know, right? The top FA man looked and said, cripes sake, let's just tell every mechanic to carry a 4-foot screwdriver and forget it. Then I argued about a screwdriver. I really wanted it to be a hammer, but but you know, that tubular spar, that was another area that we got a lot of criticism from the so-called engineers that were around, and because an I-beam, that's the way, boy. The textbook tell you how to make I-beams. They're the world's greatest thing. Well, they are. They're good for one kind of load, but you try and put a different load on it, and they're ridiculous. And if you try to twist it, they're absolutely no good. And a wing is that way. The wing has to take a lot of lift, but sometimes it gets dragged to it. Sometimes at high angles of attack, it's actually a forward load on it, and they always twist. So with the I-beam, you then have to put a second spar, you got to put a decap, you got to do a whole bunch of things, and every one of those things are critical. You make a wing, for example, with a strut on it. The spar is a very important part of your wing, but so is those cotton-picking little struts. One of those bolts are missing, doesn't make any difference how strong that spar is, that wing's long gone. And anytime you have those kind of parts, they've got to be designed right, they can conceivably be put in wrong, they conceivably can be a stress concentration, and so on. So as we evolved, and designer never starts off with a real simple design. You always start off complicated, but the more you work on it, the better it gets and better it gets, and finally we get down to the tube. And all of a sudden that darn thing was strong this way, and strong upside down, and strong in twist, and strong forward, strong back, and it was very inexpensive. We'd buy the thing from Alcoa, literally by the pound. And here it has no machine parts on it, no stress concentrate, no fatigue points, no nothing. Just one good, solid beam out there. Now, it violated the so-called structural engineer's handbook as to what's good, but they can take that handbook and throw it into a small river or a big river. I didn't care. The thing is, it really does work, and it does a good job. So when we laid it out and started putting the thing in there, we found that we could do a real good job with it. And it took many, many years later before other people said, hey, you know, that's not such a bad idea. And I said, great, I'm glad you're thinking about it now because we're on better ones at this point. But the Yankee, when we started certifying, the idea of using the bottom material was without a doubt an excellent way to go, but the big problem was to get it through FAA, get the certification. FAA is there because they need to be there in some sense, and they do some good, but unfortunately they do some harm. You can actually make an airplane safer, stronger, better, and everything else if they weren't around. Because we know now enough about technology and everything else that we don't have to have a watchdog looking over it. But you know, that's the law of the land, that's what we must do, we got to follow it. So you do the best job you can. But like, let's take that bonding structure for example. On any other light airplanes, the Cessnas, the Pipers, and all those other things, they use skin gauges of 020 or 025 or something like that. And they use an 1/8-inch rivet. This is pretty much standard throughout. And your rivet spacing might be anywhere from 1 inch to 1.5 inches to maybe 2 inches apart. Well, any one of those rivets in that kind of skin gauge will take about 300, 350 pounds before it shears in half. 1 square inch of that bonding material would take 4,200 pounds. We could have actually just put spots of 1/8-inch diameter bonding along there every 2 inches, and it would have been as good as a riveted airplane. So when we put that bonding material that's on there, I mean, you know, you got an airplane that is chemically welded. That's what it is. It's just solid all the way throughout. And that's why they're lasting the way they are. And that's why you can have that smooth skin. I remember one time bringing a prototype. Actually, it was up to Muskegon, Michigan. We're looking at the possibility of setting up a plant there. And I land and taxi on up, and a couple people were waiting for me from the city council. And the line boy, who was a real nice guy, comes up and looks at the thing, says, man, I'm glad I don't own stock in a rivet company. I think the prototype flew in about early 1964, and it flew well. There was a lot of little changes we made, very small little things, but and we tested a whole bunch of things, different size flaps, different size aileron, dorsal fins, ventral fins, a bunch of things like that. But the one thing we knew, the airplane handled well, had good stall characteristics, good stability, very, very fast. It was just a smooth, clean little airplane. One day, Popular Mechanics needed a photograph really desperately. And we couldn't get an air-to-air airplane, so what they did, they had the cameraman stand on the ground, and I would come down real low and buzz and turn and bank and everything else so he could get a shot as if it was looking up into the sky or something. And I think I did that for about 45 minutes. This is at Springfield, Ohio. And the Air National Guard was there, and they had F-84Fs, or lead sleds, whatever they were called. And they were scooting around through the sky, and it was neat because I could just pull in and, turn inside of them, do almost anything they could do, but all within a small little envelope. And I finally landed, and when I landed, a couple people came over, and a guy I knew very well. He says, I brought a friend along. He's never been up in an airplane. He would just absolutely love to go in there, and he'd do anything go in. Well, the Yankee at this point, or the Bede one at that point, was experimental. I couldn't take somebody up as a passenger. But there was a Colt there, and fixed base operator. I said, all right, come on, I'll take you up, and I'll take you for a ride in the Colt. So we jumped in, identical engine now. Go out the end of the room and take off, and this guy's, wow, this is great, this is great. I said, no, this is lousy. This doggone truck is awful. Boy, if I thought he could have figured out how to land it myself, I would have jumped out right then. It was just... the contrast was really shocking. Had it been an airplane with a smaller engine, a bigger engine, it wouldn't have been so bad. But here it's exactly the same identical engine, and what a tremendous difference. I mean, the Colt's about the only one that, you can throw a brick out and outglide it with it. Well, I'll beat it down anyway. The brick has a better glide. I'll tell you one more story. Maybe two stories. This is a story about the circus that went around, and they had this elephant, and they would charge $1 for anyone who could make the elephant fall down on the side, and if you could, you get $500. And he would go around, and people paid $1, and people go over and jerk on the elephant's tail and pull on its leg and his ear and the trunk. And town after town after town, people after people, nobody could do it. Finally, this little kid comes up, straw in his hair, and puts up the $1. And the guy's, no, we don't want to take your money. He's, yeah, no, come on, on the cross, let him do it, let him do it. It's all right, take the kid's $1. Kid goes over and finds 2 big boards and walks around behind the elephant, takes one board, puts on the elephant's tail, takes the other board and pounds it in. The elephant lets out a tremendous roar and falls down on its side. The kid wins $500. So that night they're packing up, ready to leave, and one of the partners of the circus said, boy, we can't do that elephant trick anymore. Everybody knows how to do it. And the guy said, well, we got it. That was the one thing that we were making money on. Everything else is just a balance, and that was where our profit is. He says, yeah, but we go to the next town, they're going to win the $500. We're going to lose that. And he said, but if we don't do it, we're going to go broke. He said, well, I tell you what, we'll do the same thing, charge $1 to win $500, but in this case, we'll change the trick. We'll make it now so you have to make the elephant head go up and down and then sideways. So they do it, and they go to the next town, and nobody can do it. Next town, next town, next town. About 4 or 5 years later, they come back in the same town. Here comes the same kid. And they say, we changed the trick, take the money away. Kid goes over and gets a big box, sets it down, stands up by the elephant's ear and says, do you remember me? And the elephant goes like that. You want me to do it again? And it goes like that. So I'll tell you about the Bede 10J. Now, actually, the airplane, the Bede one, the Yankee, as it was built, as it evolved, nothing's perfect. You can always improve something, but when you really have to add it up compared to everything else, it's a 9 out of 10, without a doubt. A lot of things have been done good, and let's really get the record straight. Yeah, I did start the airplane. I did start the design. I came up with a lot of things. One of the things look at the airplane, that tail cone. I started with a block of foam on there when everybody had gone home, and I just sanded it down into the shape I want that I knew would be aerodynamically good. We made a mold on it, and I laughed like crazy because nobody's ever changed it. Nobody knows why it's exactly the way it is, and I had a pretty good reason why it should be. And it was sort of funny because that's a real easy thing to make a new change there. And, all these years nobody did it. Same thing with the fillet, where wing meets the fuselage. The back end sweeps up for a particular reason. And it's that way for a very, very definite good reason. And nobody's ever changed it. And I've got a kick out of it because it'd be nice to change a little bit. You could improve your step getting on there and a bunch of things like that. But aerodynamically, it's screwed up. And that's a critical spot there, too. That isn't done just right. You could get a 10 or 15% drag increase real quick on the thing. And what was sort of neat is a lot of things were wanted to be changed, a lot of internal things were changed, but there was a few things that all the people that's been involved in the program since obviously didn't know what it was all about, and if they don't know what it's all about, you better not change it. One of the things that in the cowling, this is something people wouldn't have known, but the cowling where the air inlet went in for the carburetor, we had a certain way, and some of the people that came in from Cessna engineering people said, oh, this is no good a way of doing it, that's ridiculous, too hard to make, and on. We're going to change it another way, we're going to put it just like we did at Cessna, and that had a flat face, and then right there was the screen. Well, when you looked at the airplane sitting there, the screen is sitting like that, but the cowling is also curving right there, and it looks like the air ought to ram in. But air doesn't believe that. Air is going to follow next to the cowling. It's going to go along the surface. The air can't run into the cowling and immediately turn. Well, the end result is they lost about 6 or 7 miles an hour in cruising speed because the engine just couldn't produce the power. And he went back and checked everything out and found out that literally the engine could never get as good of a manifold pressure. And then finally they had to admit, they said, this is what we've been doing on these Cessna airplanes for quite a while. And we've been yelling at Continental, who's been delivering the engine to us, saying, you're lying about your horsepower. Those engines can't deliver that much horsepower. And they put dynos on it in the air and found out, sure, it doesn't give that horsepower. Well, the reason is the poor little carburetor just wasn't getting the air. It was being choked off. So immediately they went back to the old hard-to-make carburetor cowling on the thing, and immediately the airplane picked up at 7 miles an hour again. As you people have seen, and those of you who've had some of the early models and everything else, there's a lot of growth potential built in the airplane. Today, I had a fantastic experience of flying. I forgot what color this little airplane is, but it's the last Yankee. I know the serial number, 459, I think it is, with a 180 horsepower engine in it. That was just absolutely gorgeous. That rascal kept shoving it, throttle in as it going down our runway, and I thought, wow, we must be right up to the full power now. And no, there was more to go, and more thrust, and more pull, and everything else. It was just beautiful. It really went good. Then I was mad that I didn't start off with 180 way back in the beginning. We had always anticipated that the airplane would have more horsepower without a doubt. I never thought anything more than 4 cylinders would go into it, and we also thought the possibility of stretching it, making it longer, 2-place and 4-place, something like that, was also a growth potential into it. And you do a lot of things in the basic concept of it to make sure you have that capability of stretching it. And some of the things you lock yourself out on. One of the things is the retractable landing gear. The configuration just makes it very, very difficult to make a retractable gear. Although talking to a gentleman yesterday, he has an idea of bringing that up and somehow making a pod underneath there. That's not impossible. It's just going to be exceedingly difficult to do. But it has a possibility, and it's something to look at. But other things like stretching it or putting a bigger engine, that's pretty much of a 1, 2, 3 things as long as you do all the appropriate things in the process of doing it. And as you've seen, the performance you can get out of it is just really astronomical. Well, let me sort of speed things along. I'll give you a little rundown on the next project I'm working on. For the last couple of years, I've been on a motorcycle, actually. It's a streamlined vehicle that gets licensed as a motorcycle and drives like a car. And I license that off, let other people do the manufacturing and the marketing of it, and send me a royalty on it, which I figure that part's pretty nice. It was fun working on it. It's interesting, but it's not an airplane, and it doesn't even come into the same class of being fun to work on. But about 2 years ago, I started playing with the computer and looking at the thing, and the little Bede 5 jet. The guys are still flying around. They're having a great time with it. And I said, yeah, I'd like to have something a little bigger, a little faster, probably 2 seats in it. Well, if you put 2 seats and then try to put 2 of those engines, you find that it's even more ridiculous than what you had before, because that engine now is around $65,000, and it's only through 220 pounds of thrust. If you wanted to make it 2-place, you absolutely have to have 2 of them, and still your thrust-to-weight ratio wouldn't be that good. Your takeoff distance would be fairly long, but the cost would be, very, very high. So I looked at different other engines, and there really isn't much at all available. There's some drone engines and a few things like this. But eventually, I got to the point of taking a look at the original Lear engine, the GE engine. It's called a CJ610, and it's 411 pounds, which is basically what a Lycoming 180 with a prop and exhaust system weighs. It's 17 inches in diameter, and it puts out 2,950 pounds of thrust. Well, that engine, I guess, is still new. You can buy them, but they don't sell many of them. They sell fan engines pretty much now, and most of the Lears are being converted and all that. So I thought, well, maybe some used ones wouldn't be too bad. And they weren't. They were way down to $50,000 and $60,000. But then the other thing I found out was that the G85, which is the military version, is surplus. And there's a lot of those around. And the prices are quite modest on that. The engine's absolutely identical, but because it was certified as a military airplane, it can never be put on a Learjet airplane. So J-85 started around $6,000 on up. So I said, all right, what if you had this little thing? It's not a big package, not a heavy thing. You can build a relatively small airplane, but you got a lot of push. But this little rascal is going to, it's also going to burn up some petrol in the process of doing it. But you know, what kind of frame could you make? What can you do? One of the things you got to really fight yourself is don't pick up the books and start looking at what other jet airplanes look like or twin engine airplane. If you really look at those and you start comparing it, and there's a lot of design books tell you to do that. You say, you know, okay, you want to know what the weight of the airplane is? Well, figure out you want 4 seats, run down the chart, look at all 4-seaters, see how much they weigh, see how much. Well, all that means is you're going to end up with exactly what they have, a little different color. Maybe you put a window someplace else, but you start with their basic ground rules, you're going to end up with a basic airplane like there. So you just got to throw that away and forget all about it. And you say, okay, what's bad about a jet airplane? Well, one of the things is that they land pretty fast and you need big runways. Well, why do they land fast? Well, because they go real fast and you can put small wings on it. You don't need a big wing and it's got a lot of thrust. So you can have wing loading to 60, 70, 80 pounds, 100 pounds a square foot. Well, that means stalling speeds of 130, 140, 150 miles an hour. Well, that means you better get moving pretty quick and you better make sure you got a lot of room to do all this in. Well, how can you land slow? The way you can land slow is put a fairly decent sized wing on it. Something maybe with a wing loading of 30 pounds or 25 pounds. Well, if you do that, though, that's going to cause more drag. Yeah, but if you got an engine already that's giving you more thrust than you need anyways, who cares about a little more drag? So you throw away all the old rules and start looking at it, and pretty soon, you know, the computer is really great because you can throw this information and say, hey, what would happen if I put a big wing on it, a relatively big wing? You find it doesn't hurt you all that much. Well, then, gee, if that's the case, why not put flaps and slots and a few other things? Let's do them all mechanical, and let's stay away from things. Fighter airplane, for example, why are they so difficult to fly? Most of us think they're real difficult to fly. Well, they are to a certain extent. Again, if that wing loading's high, you're coming in fast, you're taking off fast, you don't have much room for air. But the other thing is, they end up with all kinds of power steering systems in there. They have boosts for ailerons and boosts for elevators. And then if those go wrong, they got a backup system. And if that doesn't work, then they got some other system. Well, the poor guy that's in there, he's got to not learn how to fly an airplane. He's got to learn how to run all these darn systems. And they do go bad because they're complicated. And it gets really, really very sophisticated. And now you're carrying all this metal with you, all these extra pumps and motors and valves and safety gadgets and all that stuff. And it weighs a lot, it costs a lot. You got to have a lot of mechanics running around taking care of it. No, that's ridiculous. He said, well, do you absolutely have to have it? Well, why do you have boosted ailerons? Well, boosted ailerons mean that when you're going real fast, like 500 or 600 miles an hour, and you push the stick over, the force out there is pretty high. Well, it's high because first you got a pretty good sized airplane. So if you got like say 2 or 3 square feet of wing area, that's a lot of surface you have to push over. But what if you had a real little surface? The Bede 5, it has a half a square foot of aileron total. So it's a quarter of a square foot in each side. Well, your fat little fingers can do that bugger. And we've had it to 400 miles an hour and it's still light as can be. And there's no boosted controls on that. So don't give me this blarney, you got to have all that boosted control. But let's say the force is high. Well, what does that mean? That means at 600 miles an hour, you're not going to roll real fast. This airplane wasn't intended to chase MiGs or anything. We're not out there to see if we got the world's fastest rolling airplane. So anyways, as you carry this thing through, and it's taken 2 years, the rascal keeps getting better and better and better. And on the design, you go, and I do this a lot, you get on the design, you say, hey, this is a good way to go, you do further and further, and pretty soon it gets messy. I mean, this isn't working, that isn't working, you have to compromise here. And pretty soon you start to say, let's forget this concept, that's not going to work too good. But this one, unfortunately, is getting better and better, and nothing's turning out wrong, and that means I can't stop. I got to keep working. Well, that's hard, because I'm finally going to get some money in from this little Lightstar motorcycle, and I'm going to spend it all on this other airplane now. But when you find that you can do this, now all of a sudden you end up with an airplane that basically is not going to be much bigger than a Yankee. Well, in one way it's a little longer, and in another way it's a shorter wingspan. The wingspan's only going to be 20 feet, 20 and a half feet actually. It has 100 square foot of wing area, which will be just a little bit less than what you have right now on the Yankee. 98 square feet is what I'm actually going to have on there. Which means at normal gross weight, the wing loading is 30 pounds a square foot, which is, well, almost any light twin is that. So that means the approach speeds or takeoff speeds would be no different than a twin. In fact, it's even lower than a twin because a twin you have to wait till you get the single engine control speed, and this you would not have to. But when you land, when you run out of fuel, you're down to 18 pounds a square foot. Well, that's like a 210 or even slower than a Bonanza or anything like that. Well, now, that's a light plane. That's not a jet. It happens to have a jet engine, but it's going to fly and handle like a light plane can handle. So, this particular one is, going to have no practical value at all. It's just going to be a phenomenal. We all have been way past it. We all used to come up with excuses why we had to have an airplane, a reason why. I used to have people come in there and say, I want to buy a BD-4 because I can fly my family down to Florida once a year when we go on vacation. Big deal. You're going to work 4 years building an airplane for that one vacation you're going to do? Baloney, you wanted all those other dimes too. That's what you really wanted. So, we can kid ourselves if we want to by coming up with excuses why we want an airplane. The real reason is because we love it, we absolutely love it, and that's why we want to do it. Well, this airplane is the same sort of thing. It's not going to replace Learjet. It's not going to be a military airplane. We're not going to go out and fight MiGs again. But boy, is it going to be fun to fly. Because its normal gross weight will be less than its thrust. So you can actually go down the runway, rotate, and pull up and go straight vertical. You can get straight up to 20,000 feet if you want to. If you hold it down and wait till you get to 500 miles an hour, you can raise it up to a 45-degree angle, hold 500 miles an hour, and 58 seconds later level out at 20,000 feet. Now, it does one other rotten thing to you, too. Once you got that much thrust, where your thrust-to-weight ratio is equal to 1, it means you can probably go supersonic. So then I said, all right, let's see what happens if we want to go supersonic. 4 or 5 months ago, I was just saying it was about an 80% probability we could make everything work supersonically and still have it so that an average pilot could fly. You can do a lot of things in airplanes, and sometimes you can take them to the limits, but they're so sensitive that if you do a little thing wrong, you're in big trouble. And so that's not realistic. I mean, all right, let a test pilot do it once in a while, or some guy setting a record to do it once in a while, but not the average person to go up and start flying. Because you want to be able to sit there and relax and do a few other things. And so I was automatically going to say, yeah, the thing had enough thrust to go supersonic, but no one's allowed to go supersonic because this and this and this. Well, that was 4 months ago. And then 3 months ago, it got better, and I went to NASA and talked to them about it. And it's right at this point, it's about a 90% probability, or higher than that maybe, that the thing will be able to fly supersonic. Very nice and very comfortable. You do a little trimming when you go through it and all that. Supersonic flight, incidentally, and subsonic flight, to a lot of pilots, as I talk to them, they think it's a big magical thing. I mean, it's like out of this world as compared to in this world. No, it's the same thing. I mean, it's out there. There's just a bunch of new rules you have to play with, and the rules are a little tricky. For example, on any normal wing, the balance point on the wing is around quarter chord. That's where the first 1/4 lifts as much as the last 3/4. So you put your CG and you do all your balancing of your controls and everything else around the quarter chord. When you take any one of these airfoils and go supersonic, that center pressure moves back to the 50% point. So all supersonic airplanes have to be retrimmed for now a balance point around the mid portion of the wing. Now, if you change the planform, delta wings, for example, have a little less shift and a whole bunch of things like this, but it does get a little bit tricky. And one of the things this airplane will have is what they call a leading edge extension, like the F-18 or the YS-12 or something like that. It's a very narrow, flat little surface along the side of the fuselage. Well, what that does is sort of neat. At high angles of attack subsonically, it's like a very narrow wing out there, and the air just rolls over it like a wingtip would do it, and you get very, very little lift out of it. But supersonically, the air never knows what's happening ahead of it. For example, a wingtip, you don't have a vortice on the wingtip of a supersonic airplane when it's going. You have a shock wave that comes in there. But, well, let's say it another way. If you're driving in a car and snowflakes are coming down, you can see the snowflake move before it gets to your windshield. The reason it moves is that the air actually feels the pressure of the windshield coming, and it actually lifts the air up way before it gets to the windshield, so the snowflake is lifted up. Supersonically, the pressure cannot tell that snowflake that you're coming because it's coming as fast as the pressure is. So if you're going to drive a car at supersonic speed, which is a little bit harder to do, and you see the snowflake, this snowflake will not know the windshield's coming until it gets to the windshield. And then it will immediately know it and immediately have to move. And that's a shock wave, and that's what goes on. So you can take a wing sticking out there, and it works real good subsonically, but supersonically, that wing works just as good if it was pointing straight ahead. Very little aspect ratio. So one of the things by putting the surface way up forward, it doesn't do much lift subsonically. Supersonically, it acts as if I had it sticking out the wingtip. So now I can make that part start to work where it didn't work before, and your center pressure shifts is less, and so on and so on. It takes a lot of little clever playing around, but it starts to work. So anyways, it's going to be a home-built airplane, and Yeah, well, yeah. Look, it's not much bigger than a Yankee. It's a little stiffer metal on it at a few other places than a retractable landing gear. But just because it sounds like it's something difficult to do, it really isn't. You got to be careful, and you got to make sure you don't have too much twist in the wing, the wrong way, a few things like that, because you'll find out real quick too. But it will be an interesting home-built airplane. And I mean, they laughed about the Yankee when we started to do it. I don't know. Maybe it won't be that good. But I've logged a lot of time already on this thing flying around in my mind. I mean, I've really put a lot of hours in it already. And that's the bad part about being a designer, is when you're designing it and you're working on it, even when it's just on paper and then when you're building it, you literally run through calculations over and over again. You know what the stick forces are, what the elevator is going to act like, what the rudder is going to act like. And when you finally get in and fly it for the first time on a first flight, it's tremendously exciting to get that airplane off, but it's also almost anticlimax because you know the ailerons are going to roll the way they're going to do. You know all these things are going to happen. And it takes so many years to get to it that when you finally fly the little rascal, it's not boring, but I mean, it's obvious what it's going to do. And once in a while, you'll find something that's a little bit better than you thought, or sometimes not as good, and you have to go back to the board and fix it. But I remember the first flight on the Bede one. I took it off and climbed on out, and I didn't think the rudder pressure would be as light as it was. And I start making turns, and the balls flying all over it. It almost crashed the glass out of the side of that little turn and bank indicator. And the second turn, the same thing. I finally said, Jimmy, you dummy, you know what you're not supposed to do. You're pushing too hard on the rudder pedals. If you can't push it right, at least put your feet on the floor and don't do it so bad. So next turns were my feet on the floor, and they were better. And I said, all right, let's back on the pedals and do it nice and gentle and everything else. But that was about the only thing that I mentally miscalculated when I flew it the first time. But as far as how the ailerons handle, as far as the stall went, as far as the elevator and all the other handling characteristics, pretty much just about the way I wanted it to be all the way around. Well, if anybody has any questions, I'd be happy to try and answer some of them.
Can you tell us a little more about empty weight, gross weight, fuel consumption, anything like that on an airplane?
Which one?
On BD-10.
The 10. The empty weight will be 1,300 and about 40 pounds. Dry weight, this is what I call. It's going to have 2 fuselage tanks, rubber bladders in there. One will hold 1,000 pounds of fuel. So with the pilot and the second person in there, I'm looking at a normal gross of around 2,750, which is, it's a lot less than a Bonanza, I guess, but summer is like a 182 gross weight. Now remember, when you're talking about gross weights here of like 27, there's a lot of things it's going to handle just like a 182 would do. I mean, it's inertia, it's bouncing around and a few things like that. Now there's going to be a second tank, which will carry 800 pounds more, and that's for cross-country flying. It will cruise, we're expecting to cruise at 1.6. I mean, it's capable of going up to 1.6 Mach number. But normal cruise will be around 0.9, which will be around 575 or 600 miles an hour. With the 2 tanks on it, it'll have range of somewhere around 1,500–1,600 miles. Depends on altitude an awful lot. So I did a lot of calculations for 30 or 40,000 feet, but also for 18 or lower, because a lot of times somebody wants to go someplace with this thing and he doesn't want to file IFR, so you want to stay below 18,000. At 40,000 feet, with the engine in idle now, it'll do about 510 miles an hour. So you cruise just barely above idle. The engine's just so big that all you're going to do is give it full throttle maybe on takeoff, rotate a little bit, and start bringing the throttle back. One problem is making a landing with it, because idle thrust is about 140 pounds at slow speeds. And 140 pounds of pushing all the time when you're trying to land a little bugger, even though you're coming in slow, it's gonna make your brakes work a little. I don't want to put a thrust reverser on it. The Bede-5 has, incidentally, a thrust reverser. We don't actually give the engine any power when we do it, but we put the thrust reverser on the ground to get rid of idle thrust. And that one had about 40 pounds of idle thrust. That total cost for that thrust reverser, I think used to be $14. Now it's up about $18 worth of metal. It's just a couple of pieces of stainless steel and a big push-pull cable. A thrust reverser for a Learjet or something like that, they're $30,000 or $40,000. So I can't make a $12 one for this one, but I sure don't want to put a $40,000 one on this other airplane.
What about gas consumption?
Yeah, that varies tremendously from a big amount to even bigger amount. No, the fuel flows on it will go, well, if you went full throttle, a normal jet engine will burn about 1 pound of fuel per hour per pound of thrust. So it'll burn 3,000 pounds of fuel in an hour if you could leave it wide open on the ground. You can't do it. Sea level, you're just going to go supersonic so fast, and we won't approve of supersonic speeds right on the deck because the air is too dense. You should only do it when you're up higher. But as soon as you get up real high, the air gets real thin, and it starts getting down into the neighborhood of 300 or 400 pounds of fuel. Now, 6 pounds of fuel is 1 gallon. So you're, maybe 100, 200 gallons or something like that, cruise on it. So with the total of, I think the maximum fuel on there can carry is about 300 pounds of fuel. You can go 300 gallons, I'm sorry. You can go about 1,500 miles with it. It's not a real inexpensive airplane, but it's not like a 727 or something like this. The engine is going to be flying around in a low power settings almost all the time. The airplane's being made for maybe 3 categories. One, some guys that like to do airshow work like the Bede does. They'll make a spectacular airshow airplane. 2, there might be a few people who have enough money who can fly their own airplane and want to use it for cross country. And 3, I want one. And maybe I'll only make one, but yes.
Is it possible to pressurize it, and it being an experimental airplane, isn't there a height restriction?
No, an experimental is not a height restriction. Pressurization, I'm making the cabin now to take pressurization. I don't know if I'll have it on there right in the early stages, but it'll be capable of upgrading to it. And you have to do a bunch of crazy things with the canopy. So it will be pressurization. Not true. And there's a possibility this airplane actually is small enough that at 30 or 40,000 feet, the sonic boom will be so low that it will be no objection. So we may be legally able to fly. Otherwise, you have to do it out over the water. So I can start down at Hammond, Indiana, and get up here real quick if I'm over the lake like that. At supersonic speeds, it'll have a range of just a little over 500 miles with takeoff, climb, and a little bit of reserve coming down.
How much?
How much? No, you don't want to ask. It's going to be like the engine, of course, is a major thing, but the used J85s, I think good ones can be had for somewhere in the neighborhood of $15,000, $20,000. The $6,000 ones are pretty high time on it. Those engines are good for 5,000 hours, and this airplane, you're not going to put a lot of time on it. One of the guys I'm working with very closely operates 5 Learjets, and he also has an engine overhaul facility. And one of the things he's indicated that since you cruise this thing at low power settings, your tailpipe temperatures are down low. And if that's down, he thinks this thing could go 10,000 hours or something like that. You can get pretty extended life out of those engines. It is single engine, so you don't want to start using it for hauling the president of one of the 500 corporations around the country or something like that. You got limitations there, but the Lycomies and the Continentals work real good on one engine too, and actually a jet engine is even more reliable. It's easier to operate. It has less chance of breaking.
How would you compare this to the Super Pinto?
It's a lot smaller and it's a lot cleaner. And the Pinto was designed as a trainer. It has a relatively fat airfoil on it for a jet airplane. It's a relatively big cockpit. It was designed to have 2 big ejection seats and all that. And the Super Pinto put exactly a J85 in it. And they can sit there and they can go uphill like that. But their gross weights are still up around 7,000 or 8,000 pounds. This would be a gross weight maximum be 3,300 pounds. And it's like taking a Learjet and cutting the weight to 1/3 and still leaving those 2 big engines on there. And the Learjet does pretty good even at its own weight. So.
What type of construction are you planning?
The construction on the airplane would be 60% would be metal. The main wing structure is metal. The main fuselage structure, the aft section is metal. Major portions of the fin and the stabilizer and elevator are metal. Then the rest are composite. The cabin area will be a sandwich composite structure. The leading edge is composite. Flaps and ailerons are composite. It looks like a little F-15. I have an information yet later on when this whole thing's over. Everybody wants to look at the 3-view and the inboard profile. The average, but the best way to describe it looks a little bit like an F-15. It's a high mid-wing, swept leading edge, straight trailing edge. If it doesn't fly, I know it's going to taxi good though. I got a mock-up started, and this time I'm doing most of the engineering first and getting most of the drawings done. I'll probably start cutting metal in a couple of more months. It's a little hard to say because if I had nothing else to do but that, I'd be on it right away, but I do have to play around with a couple other things.
Go to conventions.
Yes.
Really exciting to hear about such a neat project, but for something in a price range that most of us can afford, can you tell us what new developments you have for your 4 model?
Yeah, the Bede 4 is a home-built aircraft. I do think I'll be able to reactivate that as a home-built kit here, probably within the next 6 months. And there's a little Bede 6, which is a scaled-down version of the 4, but it's only 1 seat. And it would have, well, we had the original Hertz engine in, the same thing we had in the Bede 5. But now there's a number of good ultralight engines in the 40 to 45 horsepower category. And that airplane was really small, and you sit in it, and you felt like you're in a Cub. And it would, on a 45 horsepower engine, we could easily cruise at, 148, 150 miles an hour. And I used to call it my supersonic Cub, because that's just the way it felt like it was in there. Those would both be home-built airplanes. There's some serious thought about the possibility maybe certifying the 4 and actually making a production airplane. Ideally, if that primary category came along, or some of these other new regulations come along, the 4 would be an extremely good airplane to bring out. To be real honest with you, if that primary category would be possible, where you can get it certified and maintained and upkeep good, I would almost make a new version of the Yankee, and probably, well, if the regulations say 4 seat, they'd probably make it for 4 seat, 2 and 4, and if they won't let 4 seats in, just 2 seats. But I'll tell you, it'll end up looking an awful lot like the Yankee then. But I would use different materials and different construction methods to really cut the cost down. I'll tell you this, there's just no question about it. An airplane can be made that's real good, real strong, real efficient, and darn inexpensive. And I heard the other day talking about the replacement parts and $300, $400, $500 for ashtrays and various things like that. And it's high, but the other guys are even charging higher. And so, it's bad, but you almost have to put them, you don't have much choice. And it's sad because the mechanics aren't making the money. The builders, the manufacturers aren't making that much money. It costs them a lot. I mean, as we were talking the other day about that boot, the fuse that they have to make it on. It's the whole cotton picking system. If you had to make all your automobiles out there by hand, 10 or 20 at a time per year, those things would be enormously expensive, and you could never make the kind of automobile we have. You could never develop all those things with it. I saw a study done in 1973, 72, where Ford Motor Company analyzed what it would take to make a turbo shaft engine for a car. Now this had to be a turbine engine with gearboxes to get it down to the speed to run the drive shaft. Had to have a recirculating system, so it's even more complicated than a jet turbo shaft or a turbo jet engine would be. But if they made $100,000 a year using only the technology they knew about that time, nothing new, that engine would be $830. That means if we could somehow make 100,000 airplanes a year, we could have a turbo shaft engine for $1,000, $1,500 maybe by today's dollars. An airplane is a lot more complicated, a lot more simpler to build than an automobile. If anybody tells you that they have to be expensive and this, that is just baloney. And sure, certification does cost money, and it does take time, and it is hurting. But so is tooling up for an automobile. Obviously, when you start making big numbers of something like 20 or 30 or 40,000 of them, you have to spend a lot of money on tooling too. But my desire, my goal, my love to do would be to make a good airplane that's low cost and make a whole bunch of them. Just because I absolutely love to fly, and you people do too. There's no question about it. You don't have to say a word to me. I can just look at you. You're crazy just like the rest of us. and there's thousands of other people that would love to fly too that we all know about that got pilot's license that almost given up. But there's hundreds and hundreds of thousands more young kids coming along that, gosh, if we could get them up there on a day like today with those pretty clouds and they could see that thing. And we're cheating them. We're not even going to give them a chance. They can't do it. They can be wonderful students. They can have all the mental and physical capabilities to be darn good pilots, and we just won't let them get into anything. We just won't do it. And a few might accidentally start to get flying lessons and then go out and be an instructor and then eventually work for the airline. But, they're very, very slim. But we just have to do it. Somehow, some way, it'll happen. But it's a battle. It's a battle to do. Question back there. Yeah.
Oh.
Go ahead.
It sounded to me like you were saying the Bede 1's coming back at $6,495 again. Is that right?
These guys have big memories. I can say this, it's not impossible. If everything would be done right, it's not impossible. Well, okay, let me give you some examples. The BD4 is sitting out there. It's got the tube spar almost identical to the Yankee. The airfoil is absolutely identical. But on the Yankee, I used metal ribs and wrapped skin around it and bonded it on. That's a simple process. It's a lot simpler than any of the other wings, but it still takes labor, it takes care, it takes inspection, and so on. Okay, so then I came up with the so-called panel ribs. These are fiberglass panels that are molded. And so they have the skin and a rib and a little recess, and you stack them up like you stack Dixie cups. And as a home built airplane on that BD4, I've seen many, many guys build one wing in an afternoon. Absolutely. I've seen one guy make his left wing in the morning on a Saturday and his right wing in the afternoon. And they were done. And he just stacked up these fiberglass panel ribs on there. And the wing's a terrific wing. It's solid, it's strong, it's smooth, it's easy. No inspection plates, nothing to inspect. You can now seal up these bays and make fuel tanks out of them. Instead of putting the fuel in a spar, we seal up the bays. You can seal up 1 bay, 2 bay, 3, 5, 6, any number of bays you want. You can break them up separately so you have auxiliary tanks and main tanks on. All right, but those are fiberglass panel ribs. And they still had to be made by hand, and the darn things ended up running, well, they used to cost me like $11 or $12 a piece, and then they start getting up to the $20 and up to the $30. But the one thing I did, at least for every airplane, I needed 24 of those. So even though the airplane wasn't mass-produced, the panel ribs are finally getting into some volume. But it's still, 24 times 300 or 400 airplanes a year wasn't all that big. Now there's some new material, some of the urethane rims. This can be an injection molded process. That stuff can get down to where it's about $1.10 or $1.20 a pound. There's almost no labor to it. Those panel ribs were weighing around 2.1 pounds each. So okay, I got 24, I got 48 pounds. If I got 48 pounds, and let's say it's even $2, I got less than $100 of materials wrapped up in making almost all of the main wing, plus the spars. See, there's a lot of things that can be done that way. You can't do it the way Wichita does it. You got to take these other, but those are the possibilities. And that's not some new material somebody's got all, he's working on. This has been developed in the last 10 years. It's now being used and it's now available. And that wing will be a stronger wing. You can beat it with a hammer. You can do almost anything. And never get damaged by anything. It'd be a super good wing. It doesn't have to be the wing. The tail assembly can be the way. Parts of the fuselage can be that way. The people who make aircraft wheels and brakes, they would love to make them less expensive if somebody would come along and say, just make a whole lot of them, exactly like they made the first one. Just keep doing it. The price will come down. But you come in and ask for 3 or 4 and something like that, prices are high.
You've been painting a very rosy picture here. What's the thing that's holding it up? We all blame the FAA, but maybe not.
Well, there's no one place to blame, and there's no one solution to it either. The FAA is a contributing factor, no question about it. Product liability is a contributing factor now. It wasn't before. Fundamentally, really, the major ingredient is it takes money for somebody to invest into a project like this, and it takes the guts to do it. There's no track record. You can't do it. I hope I can do something like that. I hope I can make a contribution. I tried to do it in BD5 and got that close in doing it. I didn't plan on Hertz going bankrupt, and I didn't plan enough backups to do it. The BD5 was not the solution, but it was a step in that direction. If that engine would have came around, if we could have delivered all the parts to the guys, and they would have gotten them, if we could have delivered the production airplanes. I'll give you just a little history on that. I had 3,000 kits sold, and I couldn't deliver engines because I couldn't get any. And guys started building them, and they never could finish it. I had 6,000 people ordered the airplane as a finished production airplane. Well, this is already starting to get to a little bit of production in there. Incidentally, they sell 1 million motorcycles in the United States a year. 1 million motorcycles. Harley Davidson, which is less than 3% of the whole industry, sells 40 or 50,000 motorcycles. If we could just do that on one airplane, we'd have it made. Okay. I was selling that airplane to BD5 at that time for $4,400 was the base price on the thing. To prove to you that I actually can make it, there was a company in Detroit, Creative Industries, who I was going to subcontract. They said, here's the plans, here's everything. I want you to make me 6,000 airplanes in 1 year. And he said, okay, we'll do it on a 2-shift basis, because if you get more orders, we'll go to 3 shifts. If you get less orders, we can drop down to 1 shift, and it won't really affect the cost too much. They gave me a flat price. At that time, including engine and everything else, it was around $3,200. So I could have had an airplane all painted, ready to go for $3,200. Now, I would have, had to use it to cover advertising and all the other things that go in it. And we were selling it direct, so there wasn't even a dealer discount in it. And I could have delivered a 200-mile-an-hour single-place airplane for $4,400 very nicely. And if people would have bought radios and other things like this out of, the company could have made real good money. If that would have been the case, obviously we would have gone into 2-place and 4-place and so on. Obviously, I had a lot of customers that weren't happy that we didn't finish it, but none of them were more disappointed than I was. The best part is, I know I gave it everything I could. I tried real hard. And I'd much, much rather say that I tried and didn't make it, to be sitting at home watching TV, drinking a can of beer, and say, boy, I can make a $4,400 airplane. Now, bunk, you haven't even gone and tried. What the hell are you talking about? Forget it. So, I'm not saying we can do these other things I was talking about. I'm just saying, boy, it is possible to be done. Somebody can someplace. If I get the chance, I'm going to try and do it. A little smarter this time. Oh, a lot smarter. Yes, you had a question.
Do you use, what do you think of carbon fiber? Are you going to use
Some
some of
of
that?
Yeah, there's carbon filament fibers on it as a composite, which is replacing glass as a fiberglass process. There's Kevlar, there's some of these other things. They all have their place in the right spot. There is no material that's good for an airplane all over. There's some places 4130 steel tubing is the best way. Engine mounts. No one's ever figured out a better way of making engine mounts except out of that steel tubing that we've done for years and years and years. It is a good way. So, we can keep trying new ways, but until we find something better. Some places metal's the best, some places the composites are best. A lot of those things, they all have good features and all limitations. So most of them, they come along, they're almost as a fad. The word gets out there, and the X-29 is flying with the swept forward wing. Wow, that's a big thing. Sweep the wing forward. It's all right under certain kind of conditions in a certain way, and it has a tremendous limitations. And so you can't just use it all over the place all the time. And those airplanes that fly around backwards. Where's that T-shirt? Yeah, there you are. Poor guy. No, a canard's all right under certain conditions. Most birds don't have their tail feathers up front. I used to think flying wings were the greatest thing in the world. I thought Northrop, with the design he had, that was the way anyone should make airplanes. Until you actually start calculating and figuring it out. And if you wanted to go fast, you wanted to do a few other things, you find out, by golly, you just can't make that wing lift nearly as much as you can if you put a little bit of a fuselage and a little bit of a tail on it. And the soaring people, the people who go out there for contests, they're trying to make the absolute most efficient aerodynamic thing in the world. It's not necessarily the fastest or anything like that, but they're really trying to get efficient. And I'll tell you, the state of the art in soaring circles is phenomenally good. They are much further ahead than NASA is in many, many areas. And they don't care about it. Well, one of the things that they found out, if the airplane's white, it actually performs better. And therefore, you always make them white. Not because you have to make them white, but because you're going to win the contest if you make them white. And they also found out if you put the tail in the back, you'll make a better airplane out of all the way around. So, you guys who have those Grumman airplanes out there with the tails in the back. All right, one more question and then we'll start our call and let these beautiful trophies go out to those beautiful winners. No more questions? Great, I got to make... Oh, one more, okay.
Tell them about the zipper.
I thought you'd forget. All right, we were drinking yesterday, so I heard a rumor that you tried to use a zipper on a cowling on the Bede one and the Yankee. And I said, yeah, flew around a pattern with it once. All right, some ideas don't work. We had the cowling split right and left, and right down through here, we just put a zipper on it. As soon as fast, all those things seemed complicated. I thought, God, you can they got some good strong zippers. And, it was easy to get to the cowling, it's just that when you flew, the whole thing puffed up. Win a few, lose a lot. Hey, there were some other ones that were pretty dumb too. I tell you. Yeah.
Any improvements that you would have liked to have done on the Yankee that you were not able to implement?
Yeah, fairings around the landing gear are real critical, without a doubt. That's real important. The strut, this raw fiberglass strut sticking out there, is about 80% as much drag as one of your wings are. One of your low drag wings were. Your wings with the big flat bulges on the bottom, they're higher drag now, so it isn't quite that close. One thing easy to remember: a rod, the diameter of a pencil, 1 foot high, going through the air this way at 150 miles an hour uses 1 horsepower.
Like temperature probe.
Yeah, that temperature probe. Incidentally, that's a thing to get rid of out of it. Take it off that top part, because a couple of things. When the airplane's flying along at 130, the air behind the prop has got to go faster. That's the only way the airplane can push through the air. So at 130, I would estimate the slipstream's probably doing 145. But when it starts to climb up over the windshield, it's probably got to do 155. So you take that little probe and you stick it out there at 155 miles an hour while you're only doing 130. Stick it down near the bottom, right where the cowling is, if you can't get it out there, because by this time the air is coming straight towards the probe, it's slowing down anyways, and also if you make turbulence there, it'll stick back to the windshield. Where you put it there, if you make separation there, it's going to carry separation and turbulent flow all the way back to the back of the airplane. So clean that up. Oh, one other thing I'm thinking about too, on this nose wheel shimmy. You got it? We agreed we weren't going to talk about it next year. This is still this year. Check one thing. When that strut comes out of the airplane fuselage and turns and bends down, the shaft that's sticking down that the fork swivels on, that shaft should be 4 to 6 degrees sweeping backward. Not 3.5 and not 6.5. It can be 4, it can be 5, it can be 6, or anywhere in between. If you have it right on, 99% chance you'll never get shimmy. If it's something other than that, you have a 99% chance you will have shimmy. So, now tightening up the nut on the bottom, that's a good solution to what you now already have as a problem. If it isn't doing that, I don't know exactly the easy way to fix it. Maybe the mod people can come up with it. All you got to do is really change the way that angle's bent. You can't just readjust the airplane or how it fits in the fuselage or anything like that.
You know, the Tensile property is 4340 heated to a Rockwell C62.
Picky. Get a torch out.
It's over 200,000.
All right, get a torch out and kneel the heck out of it. Bend the thing. Bend it, and then heat treat it up. It's a hard thing to do, and that's why it is as strong as it is. That's right. But all I'm telling you is somebody somewhere down the line got real clever and figured all this out one time. And it does work, and that's what the original drawings call out. That's what it should have been. But when I look at something out there, it doesn't look like it's sweeping back. And one time on the Bede one, we made some changes up in the front, and by golly, I think I was sitting at 2 degrees, and boy, I dingled all the way over to Springfield Airport that time. Shakes you pretty good. It's, you know, the old wind-up watches. That thing was wound up for a month and a half on that. But, you know, the other solution is to tighten up the nut and put more friction. The only difficulty you have then is that it's a little harder to steer with it because you're fighting the friction of that. But if it is 4 to 6 degrees, it'll work. It'll be gone.
Thank you.
What else did we do in a Bede one that was so much fun? Drinking yesterday, he said, I heard a rumor that you tried to use a zipper on a cowling on the Bede one on the Yankee. And I said, yeah, flew around a pattern with it once. All right, some ideas don't work. we had the cowling split right and left, and right down through here, we just put a zipper on it. As soon as fast, all those things seemed complicated. I thought, God, you can they got some good strong zippers. And it was easy to get to the cowling, it's just that when you flew, the whole thing puffed up. Win a few, lose a lot, you know. Hey, there were some other ones that were pretty dumb too, I tell you. Yeah.
Any improvements that you would have liked to have done on the Yankee that you were not able to implement?
Yeah, fairings around the landing gear are real critical, without a doubt. That's real important. The strut, this raw fiberglass strut sticking out there, is about 80% as much drag as one of your wings are. One of your low drag wings were. Your wings with the big flat bulges on the bottom, they're higher drag now, so it isn't quite that close. One thing easy to remember: a rod, the diameter of a pencil, 1 foot high, going through the air this way at 150 miles an hour uses 1 horsepower.
Like temperature probe.
Yeah, that temperature probe. Incidentally, that's a thing to get rid of out of it. Take it off that top part, because a couple of things. When the airplane's flying along at 130, the air behind the prop has got to go faster. That's the only way the airplane can push through the air. So at 130, I would estimate the slipstream's probably doing 145. But when it starts to climb up over the windshield, it's probably got to do 155. So you take that little probe and you stick it out there at 155 miles an hour while you're only doing 130. Stick it down near the bottom, right where the cowling is, if you can't get it out there, because by this time the air is coming straight towards the probe, it's slowing down anyways, and also if you make turbulence there, it'll stick back to the windshield. Where you put it there, if you make separation there, it's going to carry separation and turbulent flow all the way back to the back of the airplane. So clean that up. Oh, one other thing I'm thinking about too, how does nose wheel shimmy? You got it? We agreed we weren't going to talk about it next year. This is still this year. Check one thing. When that strut comes out of the airplane fuselage and turns and bends down, the shaft that's sticking down that the fork swivels on, that shaft should be 4 to 6 degrees sweeping backward. Not 3.5 and not 6.5. It can be 4, it can be 5 in between. If you have it right on, 99% chance you'll never get shimmy. If it's something other than that, you have a 99% chance you will have shimmy. So, now tightening up the nut on the bottom, that's a good solution to what you now already have as a problem. If it isn't doing that, I don't know exactly the easy way to fix it. Maybe the mod people can come up with it. All you got to do is really change the way that angle's bent. You can't just readjust the airplane or how it fits in the fuselage or anything like that.
You know, the Tensile property is 4340 heated to a Rockwell C62.
Picky. Get a torch out.
It's over 200,000.
All right, get a torch out and kneel the heck out of it. Bend the thing. Bend it, and then heat treat it up. It's a hard thing to do, and that's why it is as strong as it is. That's right. But all I'm telling you is somebody somewhere down the line got real clever and figured all this out one time. And it does work, and that's what the original drawings called out. That's what it should have been. But when I look at something out there, it doesn't look like it's sweeping back. And one time on the Bede one, we made some changes up in the front, and by golly, I think I was sitting at 2 degrees, and boy, I dingled all over Springfield Airport that time. It shakes you pretty good. It's, you know, the old wind-up watches. That thing was wound up for a month and a half on that. But, you know, the other solution is to tighten up the nut and put more friction. The only difficulty you have then is that it's a little harder to steer with it because you're fighting the friction of that. But if it is 4 to 6 degrees, it'll work. It'll be gone.
Thank you.
What else did we do in the Bede one that was so much fun? Oh yeah, we took the engine and had it so it pivoted on the right-hand side. It had vertical bolts on the engine mount, so the whole engine could swing out. You could work on the background lights. But that meant that we had to run all the control cables and everything else down the right side. Well, it also meant that that's where you run the push-pull for the throttle. And so it came in, and the throttle cable was so heavy, the thick one that I had, and I didn't want to make a lot of mechanism, so I thought I'll just rotate the carburetor 90 degrees and push the carburetor in and out this way instead of 4.5. Works real good until you get in rough air. And of course, you don't get rough air until you're flying over Louisiana with this prototype and it's swamps underneath you. And when you get rough air, it changes the float and shakes it, and the engine just starts sputtering. It keeps running, but it sputters, and it makes you pucker up real nice. I took that airplane one time. I was taking it back to Mississippi State from Houston, and I decided not to cross the Mississippi with the thing sputtering, even though I was pretty certain I had enough gas, and I would make absolutely certain maybe there's a little something wrong with the float and it isn't getting all the pressure, and that's why it's acting that way. So I saw this little field, and I came in and landed, and it was a crop dusting field. And I got in there, and I landed and taxied right up. Hangar doors wide open, people things all around, radios playing, solar. And I wait 15, 20 minutes, nobody. Go over to the gas pump. darn thing works. So I go over and fill up my airplane, still waiting, need a quart of oil, go over and get a quart of oil, put it in, wait, nobody's there. Son of a gun. So I figured out how much gas was and figured out how much oil was and wrote out a check, stuck it on there, jumped back in the airplane, started it up. And yeah, I was there a good hour and a half. Nobody ever came around, so I left the check there. But the wind, I landed on east-west runway, and the wind was somewhat coming out of the north. And so it had a diagonal runway that was heading off the heading of about 040, something like that. So I decided to use that one. But the grass was high. And I took that little bugger down to the end and gave it all it can and go roaring down there. But the grass was literally up to the bottom of the wing. It was sliding along there. And I got off. Well, it took a little longer, but I got off all right. Flew about an hour and a half and landed at Starkville Airport in Mississippi, where Mississippi State is. And where the carburetor inlet was, I still had grass all stuck up around there. It was all pointed. So it was in a pretty good weeded field. And down at the end of the runway where Stearman's had put some ruts in there, boy, I thought I was going to lose the whole airplane in one of those canals. It was. But we put that airplane through a lot of punishment. Incidentally, the prototype had the wings that you could fold on the thing. It had a little rack on the back. And I made a hitching bar that hooked to the bottom of the fuselage and pulled the tail down and the nose wheel off the ground and put it behind my car. And I probably put about 620, 630 miles of towing that airplane around on its main wheels, pulling around the country there. I didn't take it on a highway much, but around Cleveland and Columbus and places like that, it was sort of neat to use. Get a lot of attention. Okay, I'm going to call the meeting short again. Again, I want to say one more time, I truly, truly appreciate you people inviting me and having me here and let me be part of this group now. Thanks.